We see numbers and stats everywhere. Averages, polls, study results, you name it. But what's really going on behind those figures? Today, we're going to pull back the curtain on a super powerful tool that helps us find the truth hiding in the data. It's called the confidence interval. So let's dive in and see how it all works. So let me just ask you this. You see a headline, right? It says the average salary for a job is some number, or a new drug is 80% effective. How much can you actually trust that one single number? Is it the whole story? The absolute truth? Well, yeah, you probably guessed it. It's a little more complicated than that. Okay, so before we can really appreciate the solution, we've got to understand the problem. And the problem really starts with one of the most common stats we all run into, the simple average, the mean. All right, let's paint a picture here. Imagine you're a researcher, and your big mission? To figure out the true average salary for every single working person in a massive city. You'd hit a huge wall, like immediately. I mean, asking everyone, every single person in the city, it's basically impossible. Think about the time, the money, it's just not gonna happen. So what's the workaround? Well, you do what all statisticians and researchers do. You take a sample. You just grab a smaller random group, let's say 100 people, and you calculate their average salary. That becomes your best guess. But here's the million-dollar question. Is the average from your little group of 100 people the exact same as the average for the whole city? The answer is almost definitely not, right? If you went out and grabbed a different 100 people, you'd probably get a slightly different number. Every sample you take gives you a new estimate, a different piece of the puzzle. So, what do we do with all this uncertainty? Okay, this is where statistics gets really, really smart. Instead of just pretending we found the one perfect number, it gives us something way more honest and, frankly, way more useful. It gives us a range of certainty. The core idea is simple but powerful. A single number can be misleading. It's like trying to describe a whole landscape by looking through a keyhole. But a range of likely values, that gives us a much clearer picture. We're not saying the average is exactly this. We're saying, hey, the real average is very, very likely somewhere inside this window. And that special range, that window, it has a name, the confidence interval. And that's pretty much the simple definition. It's a calculated range where we think the true value for the entire population, like our city's real average salary, is probably hiding. All right, let's peel back another layer and get a bit more precise. Because, there's the simple way to think about this, and then there's the way a real statistician thinks about it, which gives you a much deeper insight. So the simple view is what we just talked about. The true average is probably in this range. Easy enough. But check out the expert view. This is cool. Imagine you could do your survey not just once, but 100 times, 1,000 times. Each time you calculate a new confidence interval. The expert view says that about 95% of all those different ranges you create would actually capture the true average. It's a small change in thinking, but it's huge. It means our confidence isn't just in one answer, it's in the method itself. So how do we actually build this range? We're not going to get bogged down in the math, but it's basically a recipe with a few key ingredients. You've got your sample average, of course. Then there's your sample size. The more people you ask, the more precise your range gets. It gets narrower. You also have to look at how spread out your data is. If everyone's salary is pretty similar, your range will be tight. If they're all over the place, it'll be wider. And last, you pick a confidence level, basically how sure you want to be. Okay, let's talk about that last part, the confidence level. This is super important because it's where we decide how certain we want to be that our range actually caught the true value. The two most common levels you'll see are 95% and 99%. Each one has a special number, a z-value, that goes into the formula. Now there's a trade-off. If you want to be 99% sure, your range has to be wider to be more conservative. If you're okay with 95% sure, you can get a slightly narrower, more precise range. But for the most part, across pretty much all fields, science, medicine, you name it, 95% is the gold standard. It's just the sweet spot. It gives you a really high degree of confidence, but it doesn't make your range so huge that it's useless. So this quote right here, this is your key takeaway. This is the simple, straightforward way to think about it in your everyday life. When you see a study that gives a 95% confidence interval, it just means you can be 95% sure that the real answer for everybody is somewhere in that range. That's it. Simple as that. Okay, that's the theory. But how does this stuff actually play out in the real world?
Let's walk through a classic example to see it in action.
All right, let's say you want to know if there's a real difference in average salary between men and women. Again, you can't ask everyone, so you take a sample. And in your sample, you find a difference. But here's the question. Is that a real difference that exists in the whole population, or did you just get a weird sample by chance? This is where the confidence interval is clutch. You calculate the confidence interval for that difference. And now for the magic trick. If that calculated range of possibilities does not include the number 0, boom. You can be confident that there is a real statistically significant difference in the entire population. You just went from a hunch in a small group to a powerful conclusion about everyone.
So, the big thing to remember is this. A single number is just an estimate. It's a starting point. The confidence interval, that tells you the rest of the story. It shows you the range of possibilities and just how certain we are. So, from now on, when you see a statistic, don't just nod and accept the number. Be that person in the room who asks the smartest question. Yeah, but what's the confidence interval? Thanks so much for joining me for this one.